All right, welcome to Geometric Sequences and Series. I'm going to do this in two parts. We'll talk about just what a geometric series or sequence is and how you can write it pretty quickly. And then we'll look at how you can actually add the elements of a sequence together, which is called finding the sum of that series. Okay, so a lot of this is similar to what we did with arithmetic sequences. The difference is with a geometric sequence, the ratio of the terms is called the common ratio. Oops, I had a wrong marker there. Whereas before we called it the common difference. So slightly different terminology, and it's a different process as well. So the idea is that you're multiplying the term 1 by something to get term 2, and then you're multiplying that same thing the whole way through. So you would multiply term 2 by the same number to get term 3, and so on. And what that number is called is the common ratio, and we use the letter R for it when we talk about our geometric sequences. Now, if you look, we're actually saying if this is our sequence, if we take any term and divide it by the term right in front of it, we're going to get R. And that's what you're seeing written here. All right, so to figure out whether or not a sequence is geometric or not, you just have to take one term and divide it by the term in front of it. So if I do 4 divided by 2, I get 2. And then I'll do that same thing, but I'll pick a different pair of terms. So I pick term 8 and I divide it by, I pick 8 and divide it by 4, and I get 2 as well. And then I would verify it one more time, take 16, divide it by 8, and I also get 2. So 2 is what R would be for our sequence, and yes, it is geometric. All right, so I want you to try part B and part C. So pause the video, come back and check your answers. Okay, so when you look at each of these, they were both geometric. The idea is, guys, you take any term, you divide it by the term right before it. And as long as you get the same number every time, you know it's geometric. And that also tells you what your R value is. So the B wasn't too bad. C, you had to divide some fractions. Shouldn't be too much of a problem. If it is, if you're struggling with that, grab your calculator, do it on your calculator. You know how to do it at this point. And we get negative 1/3 every time we take any number in the sequence and divide it by the previous term. So both of these are geometric, and the reason we show you this process of taking a term and dividing by the term in front of it is a quick way to figure out what your R value is if you know your sequence is geometric. So to figure out an equation for any geometric sequence, we have kind of a similar approach that we took in writing the equations for arithmetic sequences. You look at the fact that when you start with A1, you're going to multiply by R to get A2. So pretty easy to figure out what A2 would be. But then you take A2, multiply it by R again, and you get A times A1 times R, which we can write as A squared. And then you continue that process, and the thing that's important here when we start looking at this is comparing, what's our term that we're finding, and look at the exponent on R. And that should give you a little bit of a clue as to what your equation might be. So it's always going to be A1 times R to some power, and that power ends up being 1 less than the term we're finding. So n minus 1. Now there is a way to do this in Algebra 1 you learned, where you wrote it for the 0th term. If you remember that, go for it. If not, this is how we're going to approach it for this class. So in order to write the nth term of any geometric sequence, we need to know two things. We need to know the first term, so term 1, and we need to know the common ratio. And if we know those two things, we can write the sequence. Okay, well, let's try a couple of examples. I'll do one with you and have you try one or two of these, and then we'll talk about them. So we have, the question says, write the expression for the nth term of a geometric sequence. It's important that we know that, because then we know what form we're writing, whose first term is 3 and common ratio is 2, and then find the 9th term. So there's a lot of information here. First thing we have to realize is that they give us the first term. This is A1. They also tell us the common ratio is 2. That gives us R. That's the first step. Let's figure out a way to write the nth term. So just like we talked about it a second ago, you take a1 times r to the n minus 1 power. Well, in our problem, so what we're given is that r is 2 and a sub 1 is 3. So now I can actually write an expression for that sequence. So I would have a sub n equals the first term, which is 3, times 2, which is our r value, raised to the n minus 1 power. Now that expression allows us to find any term in the sequence. That's why we label it as a sub n. So the second part of this problem right here asks us to find the 9th term. So the 9th term we know could be written as a sub 9. Now what that tells us is that anywhere we see n in our formula, we're going to replace it with 9. So we'll have 3 times 2 to the 9 minus 1 power. And then we just have to do a little bit of evaluation here. So 3 times 2 to the 8th power. Go ahead and grab your calculators. And you think you're going to get 768. So the 9th term is 768, and this is the nth term. Okay, I want you to try part B. So again, pause the video, see if you can come up with it, and then come back and check. All right, so the first thing I did, of course, was to write an expression for a sub n using my first term, which was 20, my common ratio, which is 1.05. Now I put it in parentheses because it's a decimal, but you don't have to. Now I'm going to use that to then find a sub 15. So I'm finding the 15th term by replacing n with 15 and evaluating. And I used my calculator for that. Okay, why don't you go ahead and try part C as well, come back and check your answer, and then we'll do D together. So once again, I used the pattern that I was seeing and wrote my nth term. Now I did use that process we talked about before, which was taking any term and dividing it by the term in front to actually figure out what r is. I was given my first term, so I can write my equation pretty easily. A sub n equals the first term 5 times the common ratio of 3 to the n minus 1 power. I've got my equation. Use that to find a sub 12. So plug in 12 where you see n, and we get 3 to the 11th power times 5, which is a pretty large number. So by the 12th term, we've got a really large number because every time we multiply by 3. All right, let's try this part D together here. The key to all of these problems is that they tell us that it's geometric. Without that information, this might be a little more challenging. All right, so this time I'm given the 4th term and the 10th term. Now, I don't know what the first term is, and I don't know what r is, so I've got to use a little bit of information here to figure out how to write the expression. So let's think about this in terms of, how many times did we multiply by r to go from the 4th term, so let's say this is n, so from our 4th term to a sub n, which was 125, all the way down, and I can actually write those in there. We'll write in the ones we don't know here in black, so 5, 6, 7, 8, 9, all the way down to our 10th term, which we know is 125 over 64. So what I know is this, guys. I know that if I take my 4th term, let me give us some spaces here, and I multiply it by some common ratio, so I multiply by r, I'm going to get the 5th term. Don't know what the 5th term is. That's okay. But then if I take that and multiply by r again, I'm going to get the 6th term. Multiply by r again, multiply by r again, and yet again, and one more time. And what I see is if I start with 125, so starting at 125, and multiplying by r raised to the, let's see, that's 1, 2, 3, 4, 5, 6th power, because there's 6 of them, I should end up with 125 over 64. Now I have an equation that I can solve for r. So let's solve that for r. Divide both sides by 125. You're going to get r to the 6th equals 1 over 64. And then you know how to solve this. You take the 6th root of both sides. You can use your calculator for that. And you should get r is 1/2. All right, now we've got to figure out what the first term is. So I'm going to sort of work this backwards. Now you could do this a bunch of different ways. I'm just going to show you one method here. So kind of going backwards in my table, I know that the fourth term was 125. So I'm going to work backwards to figure out what the first term is. So working backwards means instead of multiplying by 1/2, I'm going to divide by 1/2, which, guys, that's the same as multiplying by the reciprocal of 2. So that's going to give me 250, then 500, then 1,000. So now I know my first term is 1,000. I know my R value is 1/2. I can write my expression for the nth term. So A sub n equals the first term, 1,000 times 1/2 raised to the n minus 1 power. All right, if you want to go ahead and try to find the 14th term, go ahead and pause the video, see if you can find it, and come back and check real quick. All right, so hopefully you got 125 over 1,024. Maybe you got a decimal like 0.1220703. If you did, just use your calculator to turn it into a fraction. Okay, check Classroom for your assignment for this part of the week, and I hope to hear from you soon.